Okay, so we're looking at objective 10, which says interpret graphs given the meanings of the quantities represented on the two axes, right? So the phrase I want to focus on is the meanings of the quantities represented on the two axes. Okay? What's the meaning of the quantity represented on that vertical axis? Somebody tell me.
Is it temperature?
It's a temperature, and it's in Fahrenheit degrees, right? What's the meaning of the quantity on the horizontal axis?
Volume.
The volume. Okay, you don't know exactly how this graph might occur, and the graph is probably not a very accurate one for what I'm thinking of. Okay, but you don't need to know that to at least know what the meanings are, right? You might not know much about the situation, but you can at least say that whether you understand the situation or not. So you certainly don't understand the situation because I haven't told you what the situation is, okay? But I'm going to. But first we're just going to take the meanings of the quantities represented in the two axes, temperature, volume, okay? Okay, so now I've got a point. Well, one aspect of the graph is it has points on it. Okay? So there's a point on the graph. So how do we interpret the point on the graph? Here are the meanings in the context of the objective, right? So what does a point tell you? Well, it's got coordinates, so naturally if you've got a point, you automatically think, well, there it's coordinates, right? Okay? So, can we estimate the coordinates? What do you think this one is?
1,000 something.
Probably a little less than 1,000, because 1, 2, 3, it's a little more than a quarter. I'm going to say it's about 800. Okay? And what do you think this is?
160.
140.
Yeah, now if this is 0 down here, this is 200,
Oh, yeah.
but you can subdivide this interval, 100 would go about here. So I'd say it's about 120, don't you think? So I'm going to say this is the point. 800, 120. Now what does that mean?
That's the point on the chart, or on the solid.
Well, what's 800 mean?
That's the
800 centimeters.
800 centimeters cubed, right? Cubic centimeters. Because 800 is a coordinate on this axis that measures volume in cubic centimeters. So the meaning if the volume is 800 cubic centimeters, then temperature is about 120 degrees Fahrenheit. Now, is there anything difficult in this if you practice it a little bit? Here are the meanings. Everything is in terms of the meanings.
You want us to write it out like that on the quiz?
I'm sorry.
You want us to write it out like that on the quiz?
That'd be a good way to write it. Show me you understand what it means.
Like the meanings and all that?
Well, yeah, if I'm asking you for the meaning, you would maybe want to say this is the meaning. Okay?
Understood.
Don't give me sentence fragments, give me full sentences, okay? Tell me what you're thinking. You're not going to be masters of that art because you haven't had to do it in your life, but we're going to become better at it in this course, okay? So, at this point on this early quiz or test, I'll be fairly liberal in interpreting your answers. I'll give you notes, and I expect you to get better, okay? If somehow you indicate that a volume of 800 cubic centimeters is associated with a temperature of 120 degrees based on your estimates, it's going to be okay. But the better you state it, the better off it'll be, because later I'll expect better statements, right?
Yes.
Okay, so that's the meaning of this point. Now, we could have another point here. Okay, so that looks like, about, well, let's see, that's 1, 2, 3, yeah, maybe 1,800. And this, my projection line went a little high there. If I correct that, that looks like pretty close to 50, because that looks like it just about cuts that interval in half, right?
Right.
So I'm going to say this point is 1,850. And you can say what that meaning is, but that's going to be, volumes 1,800 cubic centimeters, then temperatures 50 degrees Fahrenheit. Okay?
The meaning of this graph is the more volume, the less temperature.
The more volume, the lower the temperature. Okay? So, this probably isn't one of the gas laws. Okay? I'm not going to tell you what it is. I don't want to confuse you with facts and context until it's time to confuse you with facts and context. Okay? Just want to see, literally, how do we interpret this? Don't worry about what the context is. Any graph I give you, if I have a meaning here and a meaning here with units, you're going to be able to tell me what any point on that graph means. Maybe not in context. We'll put it in context in a minute. Okay? Okay, so there we have it. There's a meaning. Now we're going to do a fundamental triangle. Okay? Fundamental triangle for this interval. So, right here is your interval. Including the endpoints. There's your interval. Then your fundamental triangle. Well, you take this endpoint and you got a point on the graph. You take this endpoint and you got a point on the graph, right? Now, I could have asked you, sketch and interpret the fundamental triangle for this interval, 800, 1,800, without having made these estimates, right? What would you do? You project up here and find this point, you find this point, you come over here and you find these coordinates, you write down the coordinates, and then you're home free, you know how to do a fundamental triangle. Okay?
Yeah.
So, that's easy to do now. So we're going to we're going to draw the fundamental triangle. And we'll see that from 800 to 1,800 is the run. That's 1,000.
Right
And
to 70.
let's get a direction here. Usually we go left to right, but if you want to go right to left, as long as you always go right to left, as long as your path runs right to left, it's okay. So your run is 100. And your rise is -70. And always, if you're going left to right, your run is going to be, well, your run is always where you end up minus where you started. Okay? And your run is always where you ended minus where you started. Your rise is, did I say that right? Your run is where you ended minus where you started. Your rise is where you ended minus where you started. Right? Okay? So there's your fundamental triangle. Now, your slope, therefore, is
-70 over there.
No.
You gotta, of course, simplify it.
I'm going to write it down here. Slope is rise over run. Remember, you do your analysis somewhere away from that triangle because you've got to label things in the triangle, and if you're on the graph, you've got to clutter things up. So over here, I write this out. Slope equals rise over run equals negative 70 over 1,000, which is negative 0.07. Now, if the numbers are ugly, you can just leave it as a fraction unless you have to use it for something, okay? These numbers are simple, it's pretty easy to get that result. So, all right, negative 70 over 1,000, but then I'll also do a decimal equivalent or maybe a decimal approximation. Okay? Make sense? So what's that mean? Negative 70 Fahrenheit degrees divided by 1,000 cubic centimeters, which comes out negative 0.07 Fahrenheit degrees per cubic centimeter. Okay? Now, what does that mean? That's your interpretation. Okay? It's the best interpretation you can give it. Now, if I want to put it in a little more context, let's say the graph shows the temperature of I'm going to call this X. I'm going to call this Y because that's what we use for column. We might call this V and we might call this T. And I'm going to use X and Y just to avoid confusion, okay? So I'm going to say the temperature Y of a chunk of food having volume X after being in a 300-degree Fahrenheit oven for 10 minutes.
Are you gonna post these like you do every other, like the picture
Yeah.
of the boards?
Anything I do here's going to get posted. Now, it's going to be a while because, like I say, I've got to go avoid getting myself drowned and, you know, get my teeth cleaned and make sure everything's good there. Okay? So I've got a couple of things to do, so I'm going to get back up here a little bit later than usual. Okay? This is what the graph shows. So now, in this context, what does 80, 120 mean? That's our 800, 120?
Could you repeat that?
What happened? Get that? What would happen if we had that point?
Happens at that point?
I'm sorry?
Say what happens at that point? Oh, he was asking at the point four.
We got the point 800, 120.
Yes.
Okay? What does that mean in terms of now chunk of food's been up?
That means,
In other words, in the context of the situation. Right, go ahead.
it's getting hot. Almost done.
We don't know how hot it has to be. 120 degrees might not be all that safe to eat, depending what it
Oh,
is.
definitely not.
Yeah, a piece of roadkill, no. Can't eat it until, well, you don't eat it anyway. Okay?
So it's in the process of cooking, if it's enough. I'm confused what you're asking.
I'm asking, what does the point 800 and 120 mean?
In that new situation. It means.
Yeah, in the context of the new situation. So, here, let's see.
800 volume, or 800 centimeters cubed will be 120 degrees after 10 minutes.
It's pretty hot, but it is done.
800, 120 tells us what?
800 centimeters cubed volume of food will be 120 degrees after 10 minutes.
Yeah, tells us that
No, that makes sense.
800 cubic centimeter
What, so volume is food, so it's 120, 800 volume.
chunk of food will reach 120 degrees Fahrenheit. Now, there's more than, after 10 minutes, that's exactly what he said. That's what it tells us. I mean, it tells us something, right? It's not hard to see what it tells us if you think about what X means and what Y means. X is 800. What does X mean? It's the volume of the chunk of food in cubic centimeters, right? So it's 800 cubic centimeters. Okay? And that's 120, that's your Y coordinate. Y is your temperature in Fahrenheit degrees. So it's 120 Fahrenheit degrees. Now, there are more conditions on this food. It's food that you just took out of the refrigerator, which is at 33 degrees or whatever, okay? So I could have said more, but there's only so much board space. I'm probably writing too small anyway. Okay. Okay.
Yeah.
Pretty simple, isn't it?
Yeah.
You just gotta learn
Just take time.
to do the simple stuff. Okay, start with what these things mean. Start with what a point tells you. It says, meaning, if volume is 800 cubic centimeters and temperature is 120 degrees. We've already got that, right? Now, when I put it in context, you can say, okay, that goes in the oven and goes up to this temperature, because that's what it's telling you. Okay? Good. Good. Okay, what's the slope of the triangle tell you?
For every centimeter cubed, you lose 0.07 degrees Fahrenheit.
Okay. Up between 800 and 1800.
Yep.
So, need a little more room here, so just this. Okay. Okay, so slope is this, and it tells you that an 800 centimeter cube piece chunk temperature drops by 70 degrees, or it is, temperature doesn't really drop.
The highest temperature reached after 10 minutes.
Temperature is 70 degrees Fahrenheit lower. Bigger chunk. Heats up more slowly. So, the between 800 cubic centimeters on the average every additional cubic centimeter lowers the final temperature by 0.07 degrees Fahrenheit. So, for example, if I wanted to estimate what an 1100 cubic centimeter chunk would end up at, that's an extra 300 cubic centimeters. I multiply that by the negative 0.07 Fahrenheit per cubic centimeter, and I get it's going to be 21 degrees lower. Now, I'm not going to push too far on that, but you want to make a good attempt to explain what this means. It's a rate. Okay, and that rate is a somewhat challenging concept, but we've been talking about it now for a couple of weeks. So I want to see some attempt here. Does that make sense? Okay, well, and what it comes down to, what I keep telling people is, well, slope is rise divided by run. Okay? The rise has a meaning. In this case, something's 70 degrees Fahrenheit lower. Okay? And the run has a meaning. It's 70 degrees Fahrenheit lower if it's 1,000 cubic centimeters greater in volume. Okay? So for every cubic centimeter greater in volume, it looks like there's going to be a 0.07 degree Fahrenheit difference in the final temperature. Okay? Now, rates can get pretty complicated. It can be difficult to understand what some rates mean. And I'm not going to give you the really difficult ones. I'll give you a little bit of a challenge. Okay? You need to learn to think in terms of rates because rates are extraordinarily important. Okay? Good.